Hello, everyone, and thank you for joining us for the newest episode of our Startup Spotlight series. My name is Anna. I'll be your producer for this session. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenter to answer live. Our session is being recorded. It will be available to view on demand right here on the Reactor channel. With that, I'd love to turn it over to our speaker for today. Thank you so much for joining.
Yeah. Hello, Anna, and hello, everyone, for joining. So today I'm going to talk about achieving 360-degree visibility into Azure Cloud, and we are going to do it with OpenTelemetry and middleware. So mostly I will be focusing on how you can use OpenTelemetry to instrument your infrastructures and applications. And we will also talk about how middleware can help you fast track that particular process. So starting off a little bit with my introduction. So I am working as a senior software engineer at a company called Middleware. So the middleware is like a hotel native full stack observability platform where we do offer different observability use cases like infrastructure monitoring, application performance monitoring. Like we help you monitor your logs. If you have any front-end applications, then we have real user monitoring. If you want to benchmark your platform, or if you want to do any heavy testing, so we can offer synthetic monitoring and browser tests. And then we also have database monitoring, LLM. So a bunch of categories we do cover to give a full end-to-end visibility to all of our users. At last, I have mentioned something called OpsAI, which is our special feature. But today I'll talk very limited about the OpsAI feature, because in upcoming weeks, like our colleagues will also be talking about in detail about the AI specific part. So yeah, with that, I'll start the conversation and I'll set the theme of the session. So the whole session will be going around how, as middleware, we can help the Azure ecosystem users. So I have divided this thing into like two portions. So first of all, we are like observability backend platform. So if someone is generating OpenTelemetry or Prometheus-based observability data, so they might need a storage, a retention, and a backend tool which can give them visualization, alerting mechanism, and a top of other like a bunch of other features on top of it. And the second goal that we try to achieve with our customers is we help them to avoid any issues coming into their production. And in case the cat is out of the bag, then we also help them find the issue, the root cause, as fast as possible. So we call it like the MTTR part, like which DevOps might relate more, like mean time to resolve the issue. So that is something we help our customers to reduce. Yeah. So to convey this particular theme, like how we help Azure ecosystem users, I have taken 2-3 categories into the consideration, like 2-3 feature sets that we have. So first of all, I'll be talking a little bit about our native integration, where we take advantage of Azure Monitor APIs. The second part, I'll be discussing about how OpenTelemetry-based instrumentation can be done in the popular Azure services, like let's say in the Azure virtual machines, Azure Kubernetes cluster, and Azure databases. And third and foremost, like I'll also discuss about how middleware can still be using OpenTelemetry and can still help to fast track the same process that we will discuss with the OpenTelemetry part. So yeah, starting off first with the Azure native integration. So what we do is Azure Monitor API gives us the access to check how all the Azure services are performing, and they have a bunch of metrics to support this thing. And what we do is like we register one particular app inside the customer's Azure cloud. That particular app has the access to the monitoring reader permission, and using that permission, like we can fetch all the required details. And as we are a hotel native backend, so we convert all of those metrics into the OpenTelemetry format, and then we showcase dashboards out of it into our platform. So I would like to showcase these part within our product itself, so the audience will get more idea. So we can switch to the browser. Perfect. So as you guys can see, like we have a bunch of integrations available. So that integrations cover like not just Azure, like we do support like all the different clouds, all the different streaming categories, databases. So our if we go to the full integration list, like we do support, let's say, more than 200 300 integrations. If I talk specifically about the Azure integrations, so here is the list of all the Azure services we do support. So that is roughly around 45, 46 services that we monitor. And inside each services, we have a list of metrics that we support collecting. So if I take example particularly for Azure Container Apps, so these are the list of metrics that we collect to show you like how your container apps are performing. Now, when I talk about these particular integrations, once we collect these data, users might want to create visualizations on top of it or create alerts on top of it, so that functionalities are also in place. So we have this dashboard builder section where we do offer dashboards for all the different categories, for all the different programming languages, databases, streaming services. If we specifically focus onto the Azure category, so for all the native integrations, we have default dashboards. If I continue with the example of Azure Container Apps, then we can show users detail about like how many replicas of their containers are running, how many container restarts are there, what is the resource utilization. And the best part is like user can pretty much edit any of these dashboards, and they can change the metrics. They can pick whatever data they want to plot. They can pick the graph types. So all the different functionalities are available, and to make things much easier for users, because if you go to a new observability platform, it will not be always easy to understand like what is the right metric to understand the use case that I want to cover. So we have also added something called AI-based chat over here. So here I can just write a prompt to my product saying that, okay, I want to create a dashboard for my Azure Container Apps, and maybe highlight all the problems in my container applications. So automatically, like our dashboard builder will create different widgets for you, and things will be easier, and only users will have to do the minor editing, applying any filters or grouping mechanisms that they usually do inside the SQL queries. So that kind of modifications they can do later on. But yeah, these are all the feature sets that we provide specifically about the Azure integration. So next up, we are going to discuss about how we can help users with different Azure services. So yeah, we can switch back to the slides, and I can discuss about the VM part. Yep, perfect. Yeah. So okay. Yeah. So if we talk specifically about the Azure VM, mostly the goal of any Azure VM users will be to see how all of the processes and containers inside the VMs are performing, and also they might want to see the performance of the applications which is running inside the VM. So I have highlighted like what is the important points that mostly our customers focus on. So they focus on like how the resource monitoring is working, how the logs are coming into the system. They might want to see if the garbage collection and other things are working fine in the application logs. So these are majority of the things that they might be interested in. So first, I will discuss a bit about like how this can be achieved with OpenTelemetry, and then we'll discuss about how middleware can enhance this particular part. So yeah, talking first about the hotel native process. So if you want to monitor your Azure VMs, then first of all, you can opt for installing OpenTelemetry Collector, which is an open source tool, which can help you collect the CPU, memory, network disk kind of data at the VM level. And once you do that, if you want to also monitor the applications running inside the virtual machine, then you would like to identify like how many services running inside the machine, and you would like to pick which ones you want to monitor for the latency monitoring, or let's say error status codes. So those kind of details you can define internally at DevOps level. And later on, there are OpenTelemetry tools like OpenTelemetry SDKs and OpenTelemetry Injector that you can use to instrument the application without touching the code base. Like at the VM level, you can instrument these applications. If you want to do some data transformation on top of this OpenTelemetry data, so let's say if you want to filter out any data before sending it to observability backend like middleware, or if you want to transform the data, or let's say if you want to enable or disable any feature set like DB monitoring or so. So for these kind of use cases, generally, if you go with OpenTelemetry, you will have to gain a little bit of knowledge about hotel config YAML file, which is their main configuration file. So yeah, users can achieve the whole goal with the OpenTelemetry setup, but this is the expertise that users might need. Now let me show you like how middleware makes this thing easier. So what we do is like we provide a single agent installation script which works well for all the different operating system like Linux, Windows, Mac OS. And within Linux, like there are different distributions like deb-based distributions, RPM distributions. So we support like all of the different distributions. Our agent will be running as a systemctl services, and what we do is like we auto detect all the applications running inside your machine, and we give a UI based option where user can pick and choose which applications they want to monitor at the API level. And for data transformation use cases, we also provide a pipeline UI where a user can transform their data, they can filter out the data. So these are the things that I would like to showcase within the product, so team can get more idea. So let's switch to the product. Perfect. So So as I was mentioning about the VM monitoring part, so if we talk specifically about the Linux machines, so within Linux, as I mentioned, we support like all the deb and RPM distributions, be it Ubuntu or CentOS, Fedora, all those distributions are supported. Now within these distributions, what we do is like we also auto detect the applications inside it. So I am running this particular demo server on my as a Azure VM, and inside this VM, like my agent has auto detected that I'm running a Java service and a few Python services as well. Now, let's say if I am interested to instrument any one of these services, so all I need to do is like check that particular service and save the changes, and the product will tell me some CLI commands to instrument this service. So I just need to run this command in terminal, and the instrumentation will start working out. So it will be like much easier instead of having your Java developer or Python developer on call, and then we guiding you to put the OpenTelemetry libraries inside it. So this will help you like skip all of that part, and from the VM level, using some of the eBPF based and some of the drop-in technologies, like it can collect the API performance details for you. So I would also like to show like how these particular data will look like. So if I particularly take example of this book management service, which is a Java service. So once I instrument it, we have this APM section, which stands for application performance monitoring. So here I will be able to see all of my services that I'm monitoring with middleware. If I specifically filter out the book management service, then I will be able to see all the different API calls that I have made inside it. And I can also see the time taken by individual APIs. So this kind of visibility we will get via the platform. And as I mentioned about how users can also transform and filter the data, so we also have something called a pipeline section. So within the pipeline section, we provide some default pipelines for regular machines and Kubernetes clusters. If I continue with the theme and talk about the Linux pipeline, so here we have different categories like logs, metrics, and traces. So in metrics and traces, like we have given the switches where user can decide to drop particular logs or particular metrics or traces. But within the logs, like we offer a much more to the users. Like users can decide from which particular path they want to collect the logs, and they can also decide if they want to parse the logs in a JSON for the JSON log processing, or if they want to mask any particular data which is sensitive. So many companies might be working with PII and other security checks. So they might want to filter out the data before they send it to any observability backend. So these features will help out in that particular case. I would also like to highlight that all the masking features that we support, so those settings will be applied at user's machine level, the agent which is running inside the machine, this that will apply this particular settings. So whatever data that user is masking, that will not even come to the observability backend, like it will not come to middleware, it will just stay in the user's network itself. So compliance wise, it will be pretty safe to be using these particular settings. We also have something called a backend control section. So this section will help to filter out the data once the data comes on to the middleware server. So it's user's choice if they want to control the data at the ingestion level or at the backend level. So yeah, that are mostly all the features that we support around the Linux auto instrumentation. Uh, One more point that I would like to highlight is we support different mechanisms of applications. So like we do support systemd services as well, and also the Docker containers. So irrespective of the mode of applications in which the apps are running inside the VM, we can help the users pretty much to instrument their applications. So yeah, that was pretty much about how we can help users to instrument their Azure VMs, and we can continue back and we can discuss about how middleware can help users with the Azure Kubernetes services. Yep. Yeah. So starting off with the Azure Kubernetes service part. So like most of the clouds provide a managed Kubernetes cluster. How our customers want to monitor these clusters is like they are mostly interested in two particular parts. Firstly, they would like to monitor the native Kubernetes components. So they would like to know that how the resource-wise the cluster is performing, like if there is any more volumes or CPU disk or other resources are required. So that is one of the important use case that users have. And another thing is like users must be running a bunch of their custom apps within this Kubernetes cluster. So they would also like to know like how these applications performing in terms of latency, in terms of error rate, in terms of is there any like the code level issues. So those kind of things people might be interested in. So first, again, I will talk about how users can set up the same thing with the OpenTelemetry, and then we'll go back to the product and we'll see how we can fast track this process. So if we talk about the OpenTelemetry specific process, so you can see here as I listed in the slide, what mostly users have to do. They will have to install a OpenTelemetry collector Helm chart. So this Helm chart will help to query the Kubernetes API server and Kubelet API server, which can help users to get all the important cluster level metrics. And then again, like users have to decide like which applications they want to instrument from API perspective, because in Kubernetes you might have multiple categories like daemon set, stateful set, and deployments. So out of these combinations, like users might want to choose which applications they want to instrument. And for instrumentation, OpenTelemetry provides a different Helm chart, which is called OpenTelemetry operator. And this operator can again help users to attach one init container or sidecar container with your main application. And that sidecar application will help to collect all the logs and what we call traces in the API monitoring world. So those things OpenTelemetry operator can help manage. And when you go with this particular setup, the hotel config file comes as a config map inside your cluster. And again, you will need some expertise in the hotel config to decide like how you want to transform the data or you want to filter out the data. So those are all the process that you have to go through once you go with the open telemetry based setup. So let us go onto the product side, and I can showcase like how we can fast track this process with middleware. Yep. Perfect. So if we go to the Kubernetes specific section, so here we can see like I have two particular cluster. So I can pick like for which particular cluster I want to do the configuration. So I'm currently focusing on one of the AKS based cluster. If you can see here, like we do support like all the different Kubernetes distributions which is out there. Today I have taken specifically the Azure Kubernetes cluster here for example. Now, as I was mentioning that once you set up the OpenTelemetry Helm chart, you will need to decide what apps you want to instrument. In middleware, what we do is we have a customized Helm chart. So with this customized Helm chart, what we can do is like we can automatically detect all the apps running inside your cluster. It can be deployments, it can be daemon set, stateful set. We also detect the right languages for this particular applications. And then if you want to instrument these applications in Kubernetes, then you might also need a few more details, like you might need to pick the approach if you want to instrument these applications via hotel native or eBPF. If you choose the eBPF approach, then there will be a sidecar container which will be monitoring the application. And if you go with the hotel native approach, then there will be a init container which will help you to do the instrumentation. So once you configure from here, which services you want to instrument. So for example, if I want to uncheck all the applications and I just want to instrument my Java service, which is the add service. So I just need to check the service and save the changes over here. And the application will just ask you to restart that particular deployment. And once you restart the deployment, like automatically our tool will attach an init container using the mutating webhooks, and the app will start getting monitored. So like things will become pretty much easier. We have some user stories in which like this particular process helped a lot, because we have customers who are having more than four and five clusters. Every clusters are running 100 200 services. So if they choose to go with the native open telemetry process, it might take them a few hours to set the whole thing, because they might need to set the annotations in their Kubernetes deployments. But with these particular process, this particular UI-based configurations, like we can complete the whole configuration within, let's say, half an hour of time. And within this Helm chart that we are offering within middleware, most of the tools are open source. So we also have this Helm chart publicly available on our GitHub. And most of the things are working on top of OpenTelemetry only. The only thing which we add to make things fast is the language detection and the mutating webhook to do the auto instrumentation. So that will make things faster for user. Now let me show you like how after configuring the data, like what is the visibility you will get in particularly the Kubernetes cluster. So starting off first with the infrastructure part. So as you can notice, like within the infrastructure section, we have a few subsections about regular VMs, containers, processes, and we have a special section for Kubernetes. So within Kubernetes, we have Kubernetes native components like clusters, nodes, pods, everything. So you can pretty much watch any particular native component. So let's say I can see all the nodes running inside my system. I can go inside any one particular node and I can see much detail about that particular node. And I can further drill down and see like which are the particular pods which is running inside my machine. So that kind of like deeper visibility you can get inside the infrastructure. If I talk again about the APM part, so the traces visualization part will be pretty much same as we saw during the virtual machine section. But I would like to also show you a few more features we have within the APM, which can help you monitor your Kubernetes apps more better. So first of all, we have something called a service map view. So with service map view, you will get something like an architecture diagram kind of thing. So here you will be able to see, okay, how my applications are connected with my database, or how my front-end applications are connected with my back-end applications. And you can see like there are some connections between these applications, like some of the connections are called HTTP, some of them are network calls, and some of them are database calls. Now I can go inside any one particular API call. So I have selected the HTTP category. And here I can see timestamp wise, like all the API calls which went from my service A to service B. And if I pick any one particular instance, then here I will be able to see that spans are coming from both of my services, my front end and backend services. So this will be more prominent in the flame graph view. So here you can see that this particular green span is coming from my front end service, which is taking about 71 milliseconds. And then I have this purple span, which is just taking 8 milliseconds, which is coming from my Python backend. And here we can also see percentage-wise bifurcation. So I can see that, okay, 89% of my time was taken by the front-end service in this particular API call, and the 10% of time was taken by my Python backend service. So in case user wants to optimize their particular application, so this will give them visibility like which service is slowing down the whole process, so they can find the bottlenecks easily. So service map view is one of the important views when you monitor applications running inside the Kubernetes. And then we also have something called endpoints view. So within endpoints view, you can see all the unique APIs which is there inside your application. You can also see the service name against it. So let's say if I am interested in seeing one particular service, so I can pretty much filter out the service. I can see API. And here you can see that for this particular API, I am getting 100% error rate. So naturally, developers would like to know like what is going wrong within my API if it is having 100% error rate. So they can pretty much drill down inside the API call, and we have the errors section. So they can go to the errors section and see what is going wrong. So here we show them exception, where they can see the minified stack trace of that particular issue, like what is going wrong at the code level. And we also take a snapshot of the function body whenever there is a stack trace in the code base. So we can pretty much see here also like on which particular line we are getting the issues. So that's how we can help users to drill down up to the code level, like what issues are coming into the system. After this point, like we can also help users to solve the issue as well with our OpsI feature. But OpsI feature is something we are going to discuss in pretty much detail within our upcoming sessions with the Microsoft Reactor. So I'll put it on the side for now, but we can also help users to solve the issues once we find out the code level issues within the system. So yeah, that is pretty much visibility we get inside the APM section for Kubernetes. And the last section we have over here is the logs, specifically for Kubernetes. So what we do actually here is we can collect logs from the Kubernetes file system. So if a user want to filter the logs based on their containers or namespaces, so they can pretty much pick like for which particular container they want to see the logs. And then they can pretty much filter out based on severity levels or other filters like namespaces. So a bunch of filters we provide on the log category. One attractive feature that we give within the log section is something called patterns. So what we do is like based on all the logs that we have received from the customer, we do like a real-time pattern recognition on top of it. And later on, this pattern recognition helps us to do the anomaly detection in case any error logs start coming within the system. So yeah, these are mostly the top 2-3 categories like infrastructure, APM, and logs, where we can help the Kubernetes users for the visibility within their system. So yeah, that was pretty much about it. Yeah, we can move back to the slides, and if there are any queries from the audience who has joined, so feel free to like put a comments, and we would like to answer those queries as well. Perfect. Yeah. So we pretty much discussed about like how OpenTelemetry helps to monitor the Azure Kubernetes cluster, how middleware makes things easier with our auto instrumentation setup, and then we also went through the product screens to see like how we showcase the resource management details, the APM performance details, and the log monitoring part. One of the interesting part that we are yet to show is the real user monitoring, where users can see how their session users can do session replay, so they can see like how their customers are going through the platform. So that is something we will visit in a minute. Before that, I would like to highlight one more use case that we solve with middleware, which is for Azure database monitoring. So Azure has a bunch of services which helps on database monitoring side. They offer this for different databases like PostgreSQL, Redis, MySQL, and a few more. Now, when we talk about database monitoring, there are mostly two kind of metrics that you can extract out of the database. So first set of metrics come from the Azure Monitor APIs. So Azure Monitor APIs will mostly give you the visibility within how your database infrastructure is working. So you will be able to see like resource-wise if database is having enough CPU, memory, disk, network, and storage limits, those kind of details. So that is you can see on the right side of the Venn diagram. And on the left side, we can see that there is OpenTelemetry based database metrics. So these particular metrics involve, let's say, bloating inside your table or any index bloating, any caching mechanism, if you have set up perfect vacuum settings or not. So these are some of the things which cannot be extracted from the infrastructure level, but you might need to have a database connection directly with the Azure DB to fetch these particular details. Because SQL-based databases like MySQL and PostgreSQL, what they do is they collect all of these metadata within the performance schema table, and we might need to query the table itself to get all of these details. So with middleware, what we can do is we can give you visibility of both of this area. So we, because we have the Azure Monitor integration, we also help you fetch the DB infra specific metrics, and also we help you to get the hotel specific metrics as well. So yeah, we can pretty much go back to the product, and I can highlight the database monitoring features that we have. Perfect. So if first I would like to show you again the DB integration part within the Azure. So here we have the specific DB integration for PostgreSQL. Similarly, we also do have the same for Redis. If I specifically go inside the PostgreSQL integration, so these are the list of metrics that we support within the PostgreSQL. Now, once you connect the integration, mostly you will need a page where you can see how your DB is performing from the Azure Monitor perspective. So we have a dashboard for it. So we give default dashboard for all of the databases. So this is the one for Postgres. So here we can see like the ingress or egress traffic coming in inside my database. I can see the storage taken by my database, CPU utilization, IOPS usage, and I can also see the storage bifurcation based on my databases. So yeah, there is a default dashboard. And again, if someone want to customize, like they can just clone this dashboard and they can modify this. And now, if we talk about the OpenTelemetry specific integration, so we have this native integration of PostgreSQL, where we collect details like number of active connections, max number of connections, database instances. So this particular database is dedicated to our native integration, which does not rely on the cloud-specific APIs. Let me also show you how users who are running PostgreSQL on a self-hosted platform, like how they can configure this particular integration. So if I go specifically inside the PostgreSQL section, and I can go inside the host agent. So I am running this particular Azure VM, and all I had to do to connect with my PostgreSQL database is I have to create a particular user within my PostgreSQL database, which have like limited permissions to just get the performance metrics of my Postgres. So here we have highlighted like all the instructions required to create that non-root user. And once a user creates that user, like they can pretty much put the credentials over here. They can put the URL, the connection URL with the database, and they can also pick which kind of metrics they are interested in. If someone is also interested in seeing the slowest query performance, then they can also enable the query sampling and top query collection kind of features as well. So yeah, this is how we help users to monitor PostgreSQL in two different ways. Like either they can go with our agent, like our agent can fetch the metrics via database connection, or they can continue with the Azure Monitor APIs. And our dashboards are pretty much flexible. So if a user wants to create a dashboard where we can see data coming from both of these sources, then they can also build a unique dashboard where they can bring data from both the things. Now, one interesting AI side of feature that I would like to show when we are discussing about the DB monitoring part is, so within our OpsAI module, we do collect all the issues coming in from our infrastructures and applications, which is, as I mentioned, we will cover in detail in upcoming sections. But right now I would like to talk about the chats part. So here what you can do is, like, you can pretty much chat with your data, like whatever observability data that you have scrapped. So let's say if I go back to, let's say, past day, or past week. So I can see like all the conversations that I have done. And I can see like 3 days back when I was setting up the database monitoring, I asked the system to tell me about like my PGDB statistics and is there anything in my system which requires attention of the database administrator. And our chat module directly gave us the information about that there is a high index bloating within the system. The table bloating is also high, and the rollback rate is also unusual. Like out of 450 million commits, like 25 million of rollbacks are happening. So these are the some of the items which requires the database administration attention. So the use case of this module is like you don't need to juggle between different modules within our screen. Like you can directly ask the platform what you want to know, and you can just chat with it, and it will scrap the details for you. A similar feature we also have while we build the dashboard, which we briefly show earlier. So what you can do is like whenever you start and create a new dashboard, we provide a chat window over here. So where you can pretty much tell your chat to create any dashboards. If you want to, after our AI builds the dashboard, if you want to tell it to change some of the settings, if you want it to change the aggregations inside the graphs, or if you want to change the type of the graph, so you can pretty much like have a two-way conversation with the AI and it will help you to build this dashboard. So these are the two AI features that I would like to highlight that can speed things up for any new observability users. So yeah, that was mostly all I had on the database monitoring part. As I mentioned, we also have one feature for the front-end monitoring, which is called real user monitoring. So I would also like to highlight this particular section. So what do we offer within real user monitoring is, if someone is having their front-end application running within technologies like Next.js, React.js, or even if they are running their apps on any mobile devices like Android, iOS, or even if they are cross-platform like React Native or so. So we do offer monitoring in all of these platforms. If I just take example of any web-based application, so I'm just going through the JavaScript section. So what we usually offer to our users is we offer a script. So what our users can do is like they can just put the script within their front-end application, and we will start collecting the sessions, like whatever user interactions are happening within the application. So once user set up the script, let me show like what is the result they will get within the platform. So here is our real user monitoring section where we give like 4 or 5 different features. One of the popular feature within this is something called Session Explorer. So here what we do is like we collect sessions coming from all the different users. If user want, they can also tag the user logged in details with the sessions as well. So here I can also get a visibility like which sessions are done by which particular user. And if I want to filter out session of a particular user, then I can also do that. Here I can see details like for which particular country or browser the user is interacting with the platform. Now I can go inside any one particular session and I can play this video like how user is performing on the platform. On the left hand side, I can pretty much see all the activities. So if user want to filter out the click activities or the error activities, then they can do so. And from here, we can also get a front-end, back-end connectivity as well. So here we can see that there is an API call which is happening from my application. So if I click over here, so again, we will get the same correlation visibility that we were seeing earlier in the APM section. So this is like one of the most important use case of real user monitoring, the Session Explorer. Other than this, we also provide something called a product analytics. So product analytics give more like a funnel view to the users, where they can see like how much users landed on their homepage on this particular time range. Like right now we are talking about past week. We can pretty much change between like the latest time range, or we can go to any particular date as well and see how things are working. After seeing like how many users are coming onto the homepage, we can also see how users are navigating through the page, and at what particular page like users are dropping the website. So that kind of visibility is also available. We also provide something called performance monitor. So here users will be able to see the statistics like FCP, LCP, INP. So these mostly helps the front end user to see how their applications are performing from the loading perspective, like how user friendly it is. We also have a error tracking section. So in this section, like we can highlight all the console or network level errors which is coming inside the system. And recently we have also introduced something called a heat map view. So within the heat map view, we can highlight within the session like which particular pages are, which particular buttons or images are having the most interaction. So within this page, you can see like this particular button is having the most interaction. So that is something we can see within the heat map. So yeah, these are all the visibilities that we have inside the real user monitoring section. So yeah, we pretty much discussed about VMs, Kubernetes, databases, and real user monitoring. We can switch back to the slides, and I would like to give some conclusion notes on how users can take advantage of these features. Again, like I would like to encourage, if there are any queries, like feel free to put in the comments. Yeah. One thing I would like to highlight, if someone is new into the observability world, if they have a bit of confusion between how middleware is different than using the regular OpenTelemetry tech stack. So I would like to highlight that OpenTelemetry is a set of tools which can help you to scrap the observability data. But on top of it, like you will need a observability backend tool, which can help you to store that data for a good amount of retention. You would like to visualize the data, you would like to create alerts on top of it, so in case anything goes wrong, like you can notify your team over email or Slack or Microsoft Teams or whichever is the comfortable platform. If once you have the observability backend and a good retention, then only you can do anomaly detection or forecasting on top of it, and the code level fixings that we discussed, so that is also something comes after the backend analysis of the observability data. So yeah, OpenTelemetry is definitely the best tool as of today, the standard tool to scrap the data out of your platform. And using OpenTelemetry, you also get a benefit that you don't get a vendor logged in, because before OpenTelemetry, there used to be some legacy platforms which were having their own format for collecting the data. But if those legacy platform users, if they want to switch to new OpenTelemetry native components, then it is a bit tough for them, because there is no standard data format that they were following earlier. But if someone is opting for observability as of today, then I would like to recommend that OpenTelemetry is the best standard to go with. So there will be no vendor lock-in kind of situation that you will be facing. Now, also, I would like to highlight that when we take advantage of all the open source tools like OpenTelemetry, we also like the community to work well. So what we do is like me and my team actively do contribute in the upstream project of OpenTelemetry as well, wherever we find scope of improvement. So all the users across the OpenTelemetry community can take advantage of these features. And I would also like to encourage all the OpenTelemetry community users to like also contribute. So like the cycle keeps going on of usage and the contribution. I would like to briefly highlight like we as of today, like there are multiple observability vendors available in the market. So why do users specifically opt for middleware specifically? So there are a few highlights that we have. So first of all, the prompt-based alternative dashboards that we saw. So we could see that based on the real OpenTelemetry data itself, like we can create dashboards without having any knowledge of the metrics or attributes or any aggregation kind of things. Like we can do prompt-based dashboard creation. Second of our USP is something called proactive alerts. So we do monitor front-end, back-end applications and infrastructures for any ongoing issues. And we put it in our OpsAI dashboard. So without any like juggling between the screens, we can highlight the issues to the users. So we call it the proactive alerts. And then we also like fix the issues for users as well. So we have GitHub and Bitbucket integrations as well. So if users are comfortable with those integrations, we can directly give the PRs, pull requests as well for the developers, so they can just verify the solution given by our module, and they can fix the issue within minutes. Now, I would also like to tell a bit about how we are planning our roadmap for Azure users as well, and also for observability users in general. So if I talk specifically about the Azure part, as of now, we are already available in the Azure marketplace, but on top of it, we are also planning to roll out the native extensions also. So with native extensions, what will be possible is if users are going to spin new Azure VMs, then they don't have to explicitly install our agents inside it. With this extension, the VM can spin up with a middleware agent included. So that is something we are having in the near roadmap. So things are pretty much easier for Azure Linux users as well as Kubernetes users. The second feature that we are, which is in the roadmap and which is already in our, I would say, beta version, which will be showcased by one of my colleagues. So this feature is called prompt-based alert building. So what users will be able to do is like they will be able to mention their use case. So let's say if user mentions that I want to get notified if my DB needs to be scaled. So users just need to add this prompt, and our system will automatically pick the right metric, right thresholds, and right collection interval details to notify the user on their favorite platform like email, Slack, or anything. And like again, like same like dashboard, like things will be easier for alert setup. And the third and a bit vast feature that we are planning to build is something called network monitoring. So with network monitoring, what we are planning to build is like many of our customers want to get visibility into how their data is flowing right from the service providers like Cloudflare and Akamai to the cloud-based load balancers, let's say Azure load balancer, and further how the data is flowing to Azure Kubernetes service or VMs or so. So customers are also interested to see like how much traffic is coming from the top level, and if there is any drop in the data, so what are the points which are becoming the bottleneck. So with network monitoring kind of thing, we can help users to answer these kind of queries. So that is one of the big projects that we are planning to pick next. At last, like I would like to encourage users to have a visit on Azure Marketplace. Like we are available on Marketplace from a few months now, so they can directly take advantage of the platform from here, or they can directly visit our website. And with the session, like we have also attached a demo request link as well, so users can also go through that and they can book a demo with the platform. So yeah, I would say that was mostly it. Again, like at the end of the session, I would like to encourage users if they have any queries, if they would like to know anything more about any particular thing, then we are open to discuss. Perfect. Yep, mostly looks like no user queries. This video will also be available on the YouTube soon. So you can also put your comments over there and share your queries over here. But yeah, good to connect with you guys. Thank you, and reach out for any of the queries. Thank you very much.
Thank you all for joining, and thanks again to our speakers. This session is part of a series. To register for future shows and watch past episodes on demand, You can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. And we'll see you at the next one.